ladies and gentlemen. So today we're going to show all the answers to this TEKS11B simplifying expressions using the exponent laws worksheet. And we'll start with number 1. So this problem uses what's called the product rule for exponents. And what it says is when the bases are the same, you add the exponents. So what we want to do here is we want to write down 3b to the second, b to the third, b to the third. Now when I write it like this, you understand multiplication is understood to exist between all of the variables in constants. This is called a constant. This is called a variable. Okay? So when the bases are the same, you add the exponents. All right? Okay? So what we're going to do is we're going to write 3b raised to the power of 2 plus 3 plus 3. Okay? So the next step would be 3b raised to the power of, let's see, 2 plus 3 is 5, 5 plus 3 is 8. So 3b to the 8. Number 2 also uses the product rule. You see that the bases are the same, so we're going to add these exponents. Right? So we have 3x raised to the power of 3 plus 3, which equals 3x raised to the power of 6. Okay, down here, it's the same thing, only we need to remember that there's a 1 in the exponent position on that second x. Again, check the bases, they're the same. And so we write down x cubed times 3 times x to the first power. That's going to transform into, we lead with the number 3x raised to the power of 3 plus 1. So that gives us 3x to the fourth power. Okay, here check again, base is the same. Okay, so we just need to add the little 1 right here. And then we'll write down 3 times 3 times 2. What I've done is I've grouped the constants together. See, the 3 2's. I'm going to go ahead and group those together. I'm allowed to do that in multiplication. Move them around as I see fit. Times p raised to the power of 2 plus 1 plus 3. So 2 plus 1 plus 3. Well, 3 times 3 is 9. And 9 times 2 is 18. So we'll lead with 18, write p. Then 2 plus 1 is 3, and 3 plus 3 is 6. So 18p to the 6th. Okay, one more easy problem, and then the complexity level goes up tenfold. So check those coefficients. Or rather, check those bases. Those bases are the same, so you're going to add the exponents. Okay. It may seem like you can do this in your head, but remember, mathematics is a writing class. It's not a mental exercise. It's certainly not a calculator exercise. So we lead with the 2, and then we write x raised to the power of 2 plus 2. It is important to show that intermediate step, not only so your teacher knows that you understand how to use the product rule, but so that you understand. 2x to the fourth. Now things get interesting. Okay, so we're going to be using multiple properties here. I see that we're going to use the power rule in the denominator, and the negative exponent rule, and possibly the product rule. and possibly the quotient rule, the division rule for exponents. So let's start with the power rule. Okay, what the power rule says is if I've got these big parentheses here and there's an exponent outside, like this -2, the first thing I need to do is distribute multiply that -2 to all the exponents inside the parentheses. Now, I've left one out, okay, because I want to, this is really, really important. Do you see this 2 right here? I always forgot when I was in algebra that this 2 also has an exponent of 1, and it must also be the recipient of that distributed power. Okay? This is a big one. This is what people always forget. So I'm going to leave everything else alone for the time being because we got enough on our plate with just that one step. And as much as most folks hate doing this, you really should rewrite this problem. Yes, it takes more time, but like I said, this is a writing class and neatness is very important. So I'm going to rewrite, and I'll go ahead and put 2 to the first times x to the second times y to the -4th, close parentheses, -2 outside. So we already know what we're going to do. We're going to leave the top the same. So that's going to be 2x to the -1st, x to the 4th. Then I'm going to drop that fraction bar there. And underneath, I'm going to write this distributed multiplication going on. Okay, so we can now drop the parentheses. We're going to write 2 raised to the power of 1 times -2. So that would be -2 times x raised to the power of 2 times -2, because I'm distributing the 2 times the -2 times the 2 gives me -4 times y raised to the power of -4 times -2. Now a negative times a negative is a positive, so this is y to the 8th, positive 8. Now at this juncture, you have multiple paths forward. You can either use the product rule to deal with these two upstairs, or we can use the quotient rule. Okay? And what the quotient rule says is if the bases are the same, you subtract the bottom exponent from the top exponent. Okay? So what I'm going to do is both. First, I'm going to do the product rule to deal with these two, and then I'll see what I got to do. All right? So I guess we'll put equals down here. We're going to go ahead and rewrite that upstairs too. And now remember, bases same, add exponents. So you have to add -1 and 4. And that gives you +3. So that's 2x raised to the power of 3 over. Now let's deal with 2 to the -2. Okay. Well, I actually don't want to deal with that right now. We'll just rewrite it. 2 to the -2 times x to the -4 times y to the 8th. Okay. Okay, now I'm going to do the quotient rule. The quotient rule says if the bases are the same, you subtract the bottom exponent from the top exponent. So what's going on under the hood here is you're going to have x raised to the power of 3 minus -4. So that's 3 plus 4. So that's going to be x to the 7th. Because it's positive, it's going on top. Okay, it's going to go up on top. So here's what we're going to write. We're going to go ahead and write that 2. And then we're going to put x to the 7th upstairs. Fraction bar. We're still dealing with 2 to the -2. This is gone now, okay? That x to the -4th, we just dealt with that. So we just have y to the 8th, which we don't have to touch. So all that we're left with now is what do we do with this 2 and this 2? Well, there's a number of things we can do. But the easiest way is to actually treat the 2 like it's a letter. Remember, 2 by itself has an exponent of 1. So you can use the quotient rule here, and you can write out what's going to happen is you're going to write out 2 raised to the power of 1 minus negative 2, which is 1 plus 2. So you're going to have 2 raised to the power of 3. That puts it up on top, okay? Now, 2 raised to the power of 3 is equal to 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. So what we're going to end up doing is we're going to put equals 8x to the 7th. We've now dealt with the denominator 2, and so all we're going to write is y to the 8th. And we're going to go ahead and put that in a red box because that was kind of a challenge. I'm proud of that. And so that would be this one up here. You see all that work there? It seems like a lot of work, but the way I think about it is, you know how you're singing a song that you know the lyrics to, or you're acting in a play? There's no way for you to mentally do the whole thing. Like, you can't do the whole play or sing the entire song instantaneously. You kind of go from beat to beat, and you kind of just roll with the punches on it, and just you keep thinking up the next step or the next lyric as you sing or whatever. You understand what I'm saying? So now we're down here. My eyeballs, plural, I have 2 of them. Notice this parentheses down here. So I know I'm going to have to distribute multiply that negative 4 through here. That seems like a good first step. So again, I'm going to rewrite this. I'm going to write x y to the 4th over 2y squared. And now I'm going to deal with this. I'm going to write times x, and then we're multiplying negative 3 times negative 4. That gives us positive 12 times y raised to the power of 4 times negative 4, which gives me negative 16. Okay? So now we observe the situation. So I got to do 2 things. I got to deal with these x's here, and I'll start there. But I've also got to deal with these y's downstairs, so I could start there. There's not any set procedure. So I'm going to go ahead and deal with the y's on the bottom first. So I'm just going to go ahead and rewrite the top, x y to the 4th, over 2, which I didn't change. And now I'm doing the product rule on the bottom. Okay? So do you remember the product rule is when the bases are the same, you add the exponents. So what's happening is we're going to have y raised to the power of 2 plus negative 16, which gives me 2 to the negative 14th power. Okay? So I'm going to write 2 y to the negative 14. It's hard to see the way I wrote it. 2y to the negative 14th power. And then we've got x to the 12th. Okay, now I'm going to do the quotient rule. I'm going to deal with my x's. I've got x to the 1st on top, and I've got the same base down on the bottom, x to the 12th in the bottom. So I'm going to subtract. What I got to do is x raised to the power of 1 minus 12. That gives me x to the negative 11th power, okay? So we're just going to write x to the negative 11th power. We'll deal with that in a second. Y to the 4th over 2 y to the negative 14th power, and nothing else because we dealt with the x in the denominator already. Okay? So now we're going to play this negative exponent game. So remember, negative exponent means if I have 1 over a to the m, or an a to the negative m, that equals a to the m. Okay? And vice versa. If I have a to the negative m, That's equal to 1 over a to the m. So you just move it around. If the negative is on the top, you move it to the bottom. So I'm going to move this whole thing to live down here. And when I do that, I'm going to change this sign to be positive. Okay? So that's my next step. I'm just doing one step at a time. I'm going to write y to the fourth on top. Put that fraction bar. And then downstairs, I'll have 2x to the positive 11th, y to the negative 14th. Now we use the quotient rule. I've got bases that are the same right here. I'm going to subtract the exponents. So that's y raised to the power of 4 minus negative 14, which is 4 plus 14. So it's going to give me y to the 18th power, and that goes on top. Okay? So I'm going to do that down here. I'm going to have y raised to the power of 18 all over 2x to the 11th. Now there's nothing else for us to do, so we are done. Okay. Look at this one. Multiple nested parentheses. Okay, so we got to deal with it one parentheses at a time. Remember, next to this m, there is a 1. Next to this 2, there is a 1 up in the exponent section. Go ahead and get that done so you know what you're about to do. What we're dealing with first is this part, okay? The inner parentheses. You work from the inside out. And so you're going to distribute, multiply that negative 1 to both of those terms in there. And again, everybody hates this, but you got to rewrite it. This takes a minute. Into the third power over open parentheses, m in to the negative first power, close parentheses, negative 1 times 2 into the fourth, close parentheses, all raised to the power of 2. So we're doing this distributive multiplication here. So that's going to give us into the third on top over open parentheses. And now I don't have to put another open parentheses. Now I can put m raised to the power of 1 times negative 1 gives me m to the negative first times n raised to the power of negative 1 times negative 1, which is just 1. Okay. And then I'm going to do times 2 times n to the fourth. This whole thing is raised to the power of 2. I'm going to recall that this 2 has a 1 as an exponent, and my next step is to distribute multiply this 2 to each of the exponents in the denominator, like that, okay? Okay, so go away. So the next step is equals n cubed over, and now here we go. M raised to the power of negative 1 times 2 is m to the negative 2 times n raised to the power of 1 times 2, so it's n squared, times 2 raised to the power of 2 times n raised to the power of 4 times 2, which is 8. Okay. Well, here's a couple of things we can do. We know 2 squared is 4, right? 2 times 2 is 4, so we can replace that 2 squared with a 4. But I also need to use the product rule because I've got the same bases down here. And so I'm going to add these exponents, and that will be my next step. Okay, so I'm going to write n cubed up on top over m to the negative second. And now I'm going to add 2 plus 8 I'm going to write times n raised to the power of 10, and then times 4. And we'll fix where that 4 is located here in a second. Now I've got to do the quotient rule. I've got bases that are the same on the top and the bottom, so I'm going to take n to the third and subtract 10 from the exponent 3. That'll give me -7, okay? So here's what we're going to write. We're going to write n to the -7th up on top, all over m to the -2nd on the bottom. We'd already dealt with the n to the 10th, so it's just times 4. Now you're really close to being done. You see these two negative exponents? You're going to move this n to the -7th. You're going to put it in the denominator and change the sign to be positive. And then you're going to do the same thing here. You're going to take this m to the -2nd and you're going to move it to the numerator and change it to be positive, okay? So we're going to do both of those steps simultaneously. We're also going to move this 4 up front, okay? So I'm going to end up with 4. Oops. I'm going to end up with m to the 2nd power on top over 4 n to the 7th. Okay. And I look at the problem, there's nothing else to do. All right. So that must be this one. It's quite a bit of work, right? Quite a bit. Well, we only have 2 more to go. Okay, so where do your eyes go first? Top or bottom? Top. Good. The parentheses, right? So we're going to distribute multiply this -1, but we have to remember that 2 has an exponent of 1. So we're going to do this. Okay. So our first step is to rewrite the whole problem. I've got open parentheses 2 to the 1st times m to the 4th, close parentheses, the whole thing raised to -1, over, oops, 2n squared. Okay, 2 times n squared times 2 times n times m cubed. So like we said, we're going to distribute this -1 here and here. So I'm going to write 2 raised to the power 2. Now 1 times -1 is -1. So 2 to the -1st. I'm treating the 2 just like it was a letter. And then times m raised to the power 4 times -1 gives me -4. Over. And now down on the bottom, we can do 2 things. We can go ahead and multiply these 2's together. But the way I'm going to do it is I'm going to treat them like letters, and I'm going to use the product rule. So instead of writing down 4, I'm going to write down 2 squared. Like this. And then I see I can use the product rule again because I've got these n's. That n has a 1, so I'm going to do n to the power of 2 plus 1, which is n cubed. So that'll be here, n cubed. And then finally times m to the 3rd power. Now, what I'm going to do now is notice that my bases on these 2's are the same. They're in the denominator and numerator, so I'm going to do 2 to the power of -1 minus 2. So that's 2 to the power of -1 minus 2 gives me 2 to the power of -3. Okay. So the other thing I'll go ahead and do is I'll apply the quotient property here because I've got these m's that are the same. That's -4 minus 3. So what that looks like is m to the -4 minus 3 equals m to the -7. And we're going to go ahead and start by putting these in the numerator. So that's going to be 2 to the negative third times m to the negative seventh over n cubed. Now we know what to do with negative exponents, right? We got to get rid of them. So we're going to move this 2 to the negative third downstairs and change its exponent to be positive. And then we're going to move m to the negative seventh downstairs, change its exponent to be positive. Okay? Those are our steps. So up on top, I'm just going to have a 1. You see, because I've moved everything away from the top, so I have to put a 1 as a placeholder up there. Then a big fraction bar, and I'll write 2 to the third power, m to the seventh power, n to the third power. The final step is just to recognize that 2 to the third power is 8. So that's 1 over 8, m to the seventh, n to the third. And here we go. Now on to the final problem. And this one really does look like a monster, doesn't it? We are going to go ahead and put a little 1 next to this whole number 2. And then amazingly, the only thing that you have to do is distribute the, I mean, we're going to do other things, but you're going to distribute that 3 right here to every term. So I noticed another 2 down in the denominator. That 2 down there also needs a 1. So this is going to look messy, but here's what we're going to do. We're going to distribute that 3 to 1, 2, 3, 4 terms on top. And then we're going to distribute that same 3 to that 2 right there, that x to the negative 2 right there, and that y to the negative 4 right there. Okay, we're going to distribute and multiply all the way across everything. And we'll go ahead and just write down the distribution results instead of rewriting the whole problem. So I'll just make a note that we are going to jump right into our answer here. So that's x raised to the power of 3 times 3, x to the 9th. Y raised to the power of 4 times 3, y to the 12th. 2 raised to the power of 1 times 3, 2 to the 3rd. Y raised to the power of 2 times 3, y to the 6th. On the bottom, it's 2 raised to the power of 1 times 3, or 2 to the 3. X raised to the power of negative 2 times 3, which is negative 6. And y raised to the power of negative 4 times 3, which is negative 12. Okay, so the next step would be look at the top. You've got bases that are the same, so you add the exponents. So we'll just do that one step here. So I'm going to rewrite x to the 9th, I'm not touching that. And I'm going to go ahead and rewrite 2 to the 3rd because I'm not touching that. But I'm going to write y to the power of 12 plus 6, which is y to the 18th power. All over 2 to the 3rd, x to the negative 6, y to the negative 12. Okay, so now we're going to play a game called Quotient Rule time. Okay, we're going to do it to multiple things. I have these same bases here with the x. I have these same bases here with the 2. And I have these same bases here with the y. Remember, you're going to subtract the bottom exponent from the top exponent. Okay. Last problem, guys. I know it's a struggle, but this is good for you. So we're going to do an intermediate step here because we're doing a lot of things. We're going to write x to the power of 9 minus negative 6. 2 to the power of 3 minus 3. Y to the power of 18 minus negative 12. And that's it. There's no denominator anymore. Okay, there might become one in a minute, but right now there isn't. So remember, these double negatives become pluses. And this gives me a chance to teach you about the zero exponent rule, because look what happens. You're going to have x to the 15th, but then you're going to have 2 to the power of 0, okay? I really want to highlight what to do when you have something raised to the power of 0. And then you're going to have y raised to the power of 18 plus 12. What's that? Is that 30?
That's 30.
Okay. Okay, so what happens when you have something raised to the power of 0? You need to write this down. This is called the zero exponent rule. Once you learn it, you won't have to think about it. Anything raised to the power of 0 equals 1. Anything. Okay? So 2 raised to the power of 0 is 1. Michael raised to the power of 0 is 1. All right. So what we're going to do here is rewrite x to the 15th. Times 1 times y to the 30th, which just gives me x to the 15th, y to the 30th. And that concludes the 10 problem assignment.